In this video, we're going to look at rational functions, and we're going to start by looking at the graphs, or by looking at parts of the graphs of rational functions. So first, just what is a rational function? It is any function that can be written in this form with px over qx, where p and x are polynomials. So in other words, it's just any function really where there's some kind of variable expression on bottom of the fraction. So we could just make one up right here. I don't know why I used r of x, but r of x would be like x squared plus 5 over x plus 1. So this is an example of a rational function. We have this variable on bottom of the denominator. When you graph these functions, they have some unique features for graphs, and one of those is a vertical asymptote. So these vertical asymptotes are these dashed lines that the graph approaches but does not cross. So the dashed lines show the asymptote, but they're not actually part of the graph. However, when we look at rational functions, a lot of times we graph these dashed lines to show that we know where vertical asymptotes are. And so here's this kind of fancy math definition, for the vertical asymptote. But what we need to know as far as practically and how to find that is you're going to find where the bottom is equal to 0. So for vertical asymptotes, if you can find where the bottom is equal to 0, then you can find the vertical asymptote, with the exception of if a factor cancels. And so we'll get into that and talk about that, because then we have what's called a hole. So a function will never, a couple notes here, a function will never cross or touch a vertical asymptote, and they're exclusions from the domain. They're your restrictions. Factor and cancel, and then set the remaining denominator equal to 0. So here is kind of the things to keep in mind with vertical asymptote. We're going to look where the bottom is equal to 0, but make sure you set the remaining denominator equal to 0. Okay, so let's do this a couple times. Let's find the vertical asymptote for these expressions. And so we'll write this, even though it was on that last page, factor and cancel. And then set bottom equal to 0. Okay, so pause the video real quick and try these. Try to factor these and cancel these, and then we'll go through them kind of quickly. So here, this bottom, we need two numbers that multiply to 6 and add to -5. And those numbers are -3 and 2. -3 and -2. And then when we set both factor equal to 0, then we get x is equal to 3 and x is equal to 2. And these are my vertical asymptotes, because nothing cancels there. Now, you can write it this way, or you could write it as a set, like 2 and 3 in these brackets. Either one is fine. Okay, number 2 is kind of tricky, and I'm going to try to get this a little zoomed in here. Number 2 is kind of tricky with this negative sign here, and we'll do this in a couple steps. So the bottom's already canceled, but if I take a negative out, then I get up top, I get 5 plus x, or the bottom's already factored, excuse me, and then this x plus 5 on bottom. Well, with addition, I can just change the order. Right, so this becomes x plus 5, and you might see that already, and this is x plus 5. So this cancels here. Those just reduce, and you're just left with -1. So when those factors cancel, that's what we call a hole. So there is no vertical asymptote, and there is a hole at x is equal to -5. So set the bottom equal to 0 for what cancels, and that gives you a hole in the graph. which is literally just that. It's just a spot. It's just a single hole in the graph where the vertical asymptote or the graph does not exist. And we'll talk more about those in another video. Okay, once again, pause the video and try this one. This is a difference of two squares. So you have x plus 2 and x minus 2. And we don't need to equal that. Set both of those equal to 0, and you get x is equal to -2 and +2 for your vertical asymptotes. And then once again, pause this video and try this one. This does not factor, but we still could like try setting it equal to 0. So I have x squared plus 4 is equal to 0. And you might see this right away. We're going to go ahead and try to solve for x. So we get x squared is equal to -4. And then when you take the square root of both sides, we get x is equal to plus or minus 2 and I. The square root of -1 is I. So this is imaginary. So there's no real solution here. So there is no vertical asymptote. Okay, so that is vertical asymptotes. Now let's take a look at horizontal asymptotes. So a horizontal line goes side to side. Let me get my. And so in this case, this horizontal asymptote would be right here. It's right on the x-axis in this example. And a line can, kind of by definition, a line can cross the horizontal asymptote. But what it can't do is cross it like as x goes to infinity or -infinity. So as we get further and further right and left, the line cannot cross. And you can find these. One thing, and I forgot to mention this in the vertical asymptotes, but use a graphing calculator. You should graph these on a graphing calculator, look at them, try to see what these asymptotes look like. You can even, like, if you have multiple functions, you can type in the function you're looking for and then also the equation for the asymptote to try to really analyze these graphs. And you also will need to, as you do that, just kind of be aware that different calculators will show asymptotes in different ways. Some are kind of funky. Okay, so here's how to find horizontal asymptotes algebraically. And this is kind of tough to remember, but you do need to memorize this. So the first thing is make sure you factor and cancel everything. And that's the same. You just do that a lot. But memorize these rules here. And when you memorize them, try to relate it to something you already know. So if the degree on top is bigger, there is no horizontal asymptote. And you already know this because if you think about something like just f of x is equal to, or you probably already know this, I should say, like this function here, whoops, the degree on top is bigger. X squared over 1, the degree is bigger, and that's just a parabola. You know what that looks like. There's no horizontal asymptote there. You didn't even know about a horizontal asymptote when you learned about parabolas. So, or even like a line, you can think about that being a function where the degree on top is bigger. So there is no horizontal asymptote there. If the degree on bottom is bigger, then the horizontal asymptote is y equals 0. And this is just your parent function graph. So the graph of 1 over x. If you want to memorize one of these rational functions, they all have this function that starts looking something like this. And it's got this asymptote on the x-axis and on the y-axis also. And if the degrees are equal, then we're going to look at the leading coefficients. So kind of for shorthand, we'll just say it's a over b. And what that means is if f of x is a over x to the n, and then we'd have b, and then there'd be some other stuff here, b over x to the n, and probably some other stuff too. But you just look at the degrees are the same, they're equal. Then you look at what is the leading coefficients and just take them out and divide them, and whatever you get is the horizontal asymptote. And we'll do this so it makes sense. Okay, so let's look at these examples here and see if we can find the horizontal asymptotes. Okay, so one thing with these, we already factored these first two, but go ahead and pause these and try them. Here, the degree on bottom is bigger, so the degree on bottom is 2, and the degree on top would be 0. And so the degree on bottom is bigger, and so your horizontal asymptote is y is equal to 0. Here, everything canceled, and our function was just f of x. This is the same one we did earlier. F of x is equal to -1. And so there is no horizontal asymptote here. The function is just, in this case, just a horizontal line. So there's no horizontal asymptote there because everything cancels. And then number 3, we can factor this. We haven't factored this one, I don't think, but this is the difference of 2 squares. But our horizontal asymptote, we're only looking at the degree. So the degree on top is bigger, and so there is no horizontal asymptote. The degree on top is 2, and the degree on bottom is 1. So you look at the exponent, the biggest exponent, to find the degree. And let's write in one more function. Let's do 3x squared minus 5 over 2x squared plus 1. Okay, so pause the video and think about that horizontal asymptote. In this case, nothing factors. And so you have that 3x squared minus 5 and then 2x squared plus 1. These degrees are the same. And so you just look at the leading coefficient. So the horizontal asymptote is y equals 3/2. Okay, and then in the next video, we're going to look at slant asymptotes and then a little bit more with holes.